3.2 is about Venn diagrams. I think we have seen Venn diagrams before. They are a visual representation of the universal set. The universal set. So it's just like trying to take what we did last time and put it to a picture. They're called Venn diagrams because the man who created it, his last name was Venn, so Venn diagrams. So they ask us to just shade in the following. Some of them are pretty simple. Some of them are a little complicated. So sometimes we might have to shade something in like lightly just to see what's going on, and then we'll make our final region dark shade. What do they want here? A what? B. What is that? A intersection B. I think that's very obvious. Like when it comes to Venn diagrams, you feel that that region right there is where set A and set B overlap each other in that spot. Are we cool with that? That's usually the first thing people think of when they do a Venn diagram. Then A union B is the next one. So that's all of A, right? Everything. And all of B, and even everything that overlaps, right? You're just shading in everything that's A, everything that's B. You don't have to waste a lot of pencil on it, Give me a decent light shade to where I can see where you shaded, And then here's the weird part. A complements. Isn't that everything that's not A? Are you with me on that? So like basically I got to shade everything in that's not A. So like you're leaving A empty. So I'm shading everything that's not A. And like I said, don't waste a lot of pencil. But do you see how the circle for A, like that set, is not shaded in? Everything else is shaded in. That is the complement of A. It's just not A. It's like, what'd you shade in? Everything except for A. You know what I mean? Everything except for A. It's kind of weird that way. But then they get into the three sets right here. So there's no parentheses on this one. It doesn't matter what order you do it in. So this is where sometimes the light shading of something helps. So the first one is like they need A intersection B. So lightly, if you want. How do you feel about that? I'm going to do my light shade in green. This is A intersection B. Are you with me on that? You can shade that in lightly if you want. Maybe you don't want to shade it in at all because that's not our answer. We still have to do that as the intersection with C complement, right? So like that little green slice right there is going to be a helpful hint in our answer, but I need to know where it intersects with C complement. And in other words, isn't C complement not in C? Are you with me? Not in C. So out of this green slice, because it's an intersection and not a union, it's like where it all happens, I just need to like either erase the part or shade darker the part that's in C, because I don't want it to be in C. And you see this little nug down here was in C. I want that to go away. And that's weird, dude. That's really weird. That is A intersection B, that original green slice that I had, where it also intersects with not C. So that's fancy talk for erase the part that was inside of set C. That's a tough one, right? We'll get better at it, though. Now let's kind of really get weird. They need A intersection B complement, right? So that's not A intersection B. Sometimes people like to find A intersection B. Again, maybe you don't want to shade because you can't erase as easy as me. Would you believe that that's A intersection B right there? What I'm supposed to shade in is everything else, right? They want not that. Are you with me on that? Not that. So kind of like in this dark shade, don't shade it though, it's all of this. This is what I'm looking for, the red region. I would like to know where that intersects C at. Are you with me on that? Where it intersects C at. So I'll let you think about it for a second. Get this. Wouldn't that be all of this weird stuff right here? I needed C, and it's not in A intersection B, so I got to even erase that green part. It's that little weird part. It's the entire C, take away A intersection B. In other words, that's another way you could look at it. Here's C, right? This all green circle is C, and I would like to unite it with stuff that's not, or excuse me, intersect it with stuff that's not in B, A intersection B. So that means I got to erase that little part right there, which my highlighter erasers don't work very well. That is a very challenging one to do. It's just weird. Do you see what I was saying? Venn diagrams can be really, really simple, and they can be really, really complicated when they start mixing in those complements to that. So we will try, and we will see how we roll with it. Here's literally a question that I snipped out of your My Open Math right here. They say, what region should be shaded to illustrate C intersection B? So they don't have a cool like shade maker tool on the computer. They just put some numbers inside the regions and do that. Could you maybe shade in with your pencil where C intersection B is? Just try that and compare it with a neighbor. Here's where I'm feeling that C intersects B at. What do you think about that? Isn't that where the entire circle C, like if I switch colors, here's circle C, and the entire circle B overlap each other at in like regions 5 and 6. So on My Open Math, they just have you list the numbers, and it'll straight up tell you in the instructions, list them in numerical order without spaces or without commas. So who's the smallest number? 5 and then 6. So you'd like literally just type like 56 in, you know, till I get that. 5 and 6. Are we okay with that? Just for fun, what if they asked you where A intersection B was? What would you write down? Tell your neighbor, what would you write down? A intersection B, just for fun. Yeah. Isn't that right there, correct? But what would you type in? 25, right? 25, right? Cool. All right. The good ones. Here's some ACT questions right here. Here's what the ACT won't have for you, a little Venn diagram drawn off to the side. So it's always nice to just sketch one if you need one. But it says, suppose set B contains 39 elements. I want to stop and talk about that right now. That means in this entire circle, there should be 39 things, right? 39 elements. They're not all over here. Are you with me? If you're like, oh, the 39 has to go right there. They could be in this little white section, too. Are you with me on that? There's just 39 things in there. What is represented by this little section? What would you call that? That is the intersection of those, right? You know, so far we know there's 39 elements in B. What I think is helpful is to maybe like put a 39 above it. You know, it's like, hey man, there's 39 things in B, because this is like a visual game. It says, so a set B contains 39 elements, and the total number of elements in set A or B is 105. Or means union, right? Or is in the union. That's like the English word for the union. So all of this unites together to be 105. Sometimes I write that like at the tippy top, you know. It's like if I put A together and B together, I get the union. So that's anything in here, in here, or in the intersection. Would you believe that I have just shaded in the union of those two sets, right? So there's 105 in the union. And it says, here's the easiest part, I think, for us to understand. Sets A and B have 9 elements in common. Could you tell me where the 9 needs to go? In region 1, 2, or 3, where should the 9 go? Region 2. That's called the intersection. Are you with me on that? That's the intersection. So we'll put them in the intersection. So the 9 goes there. Then they ask a question after that. They have given us enough information to do some figuring. Do you know how much is in this orange circle? What's supposed to be the total amount in there? 39. Are you with me? Isn't there supposed to be 39 elements in that circle? 9 of them are right here. Are you with me on that? 9 of them are right there. Can you figure out how much is in the other side right there? There's 39 total in this circle. 9 of them are here. How would you figure that out? 39 minus 9. What would you get, baby? 30. Do you see how in the entire circle there was supposed to be 39 elements, and we were told that 9 of them were in the intersection, right? So that means 30 of them had to be not in the intersection. Are you with me on that? Could you now figure out how many are in that other little piece right there, like region 1? Don't you know that all together region 1 plus this region is supposed to add up to how much? 105. So grab a calculator and let's subtract, baby. You just do 105 minus the 30 minus the 9, whatever order you're subtracting them in, and how much did you get? 66. And these three numbers have to add up to be 105. There's got to be 39 elements in set B, which there are 39 elements in set B. That's kind of weird, man. You know, that's kind of weird. We'll try another one of those here in a minute, but let's get into some cardinality of sets. Cardinality is a fancy word for count them up. Just how many things are in there. So like right now, the cardinality of set B on this last problem was 39. There are 39 elements in there, right? So the cardinality just means add them up. Sometimes they write it with these absolute value bars. That's very rarely the case. They usually just put an n in front of it. It's like, what's the number of elements in set A is like what that n is all about. So here's an easy one. What is the cardinality of P? Where P is the set of English names for months in the year. What is the cardinality of the set of English months? 12. That's fancy talk for how many months do we have, right? Aren't there 12 months in the year, right? So that's what cardinality means. What's the number of them? This one here says, use this Venn diagram over here. What is the number of elements in A intersection C? Well, I can go show you where A intersection C is. Isn't A intersection, that's a bad color to use right there. Isn't A intersection C right here? Isn't that where A intersects C in that little spot? There's 4 elements in this one spot and 1 element in another spot. What is the number of elements in that intersection? 5. All right, you're just adding things together. So see if you can find the number of elements in B union C. Here's B, and here's C. You just add them up, but you don't add things twice. You know, you just add them all up. See what you think. Let's name the two sets. You know, like, I'm not going to use A's and B's. What are they talking about? Rain and high winds. So let's use, how about R's and W's? Which one do you want to be R? Because if we all label it the same, then all of our work will look the same. The left dude or the right dude? Which one for R? Rain, wind. Work together. See what you think. Get some numbers in there. If you need a little help, we'll help you. 74 days saw rain. So that's going to go up here, meaning everybody in this circle saw rain. 72 days saw high winds, so everybody in the green circle, high winds. Add those up. What's 74 plus 72? Add those up for me. 74 plus 72. That's way more days than 113. Are you with me on that? Because they gave us the secret to the puzzle. 113 days saw either rain, and here's the magic word, or high winds. What does or mean? Say union. What does or mean? Union is what the or means. So that means everything inside here should add up to be 113. Are you with me on that? We have too much, right? We got too much. Do you know why we have too much? Because some days had both rain and high winds. That's the intersection of those two sets, right? So how would I find that? If I know I got 146 total, but it's only supposed to add up to be 113, what should you do with those numbers, baby? Subtract them. Minus 113. And did you get 33? 33 days were counted twice. So you put the 33 in here, and then we can go back and figure the other two numbers out. 72 minus 33 is 39. So there is a 39 right here. And all of these numbers add up to 72. And then 74 minus 33, hit the wrong button, sorry, is 41. Let's answer the question. How many days saw both rain and high winds? 33. Not an easy question. Let's start the last one by reading it and seeing if you could label the 3 circles. Green or orange? What do we think? The magic word is only, right? 20 people said only color and size. This green spot is where color and size intersect each other. But if I put that other spot in there, brand snuck into the party, and we don't want to deal with that, right? So we were good there. 42 people said only color and brand. So color and brand, where they only intersect, would be right here. And 53 people said only size and brand. But there's 20 other people in this survey. They said none of those. Where would that go? Yeah, outside of all the circles, somewhere. It doesn't necessarily have to be in the bottom right, but it's inside the square, right? The rectangle represents the universal set, but it's not in any of those. Now, the last question, how many people were influenced by brand? Find your brand circle and find the cardinality of that set. So we are adding up everything inside the brand circle. Isn't that 16, 42, 102, and 53, correct? What's that add up to be, baby? 213 in the hood. Cool. Let's see what we think on some homework, man. Let us know if you have any questions. Have a good one.